All right, so 3.1, integration by parts. So here, we have example number 1, number 2, number 3, number 4, number 5, number 6, all right, so which one you can integrate by using use substitution, use substitution, by using your previous course, which is Calculus 1. What number?
Number 2.
1 and
Number 2.
number 2? How about other people? You can make a chat. All right, so let me talk to you then. We can integrate by use sub. So use sub means use substitution. We did in Calculus 1. We have number 4, number 5, number 6. All right, then we cannot integrate number 1, number 2, number 3. Why? Because this is the product of two functions. All right. Okay, so for example, let's do number 4. So you said the number 4 can, number 2, you can't, absolutely we cannot integrate. How about number 6? Let's do number 6 then. Yeah, number 6. I don't want to do every number 4, 5, 6. Let's pick the number 6. All right, we have x squared sine 2x cubed dx. How do we integrate? U sub, then u equal to, what do you want to set up as u?
2x to the third.
Excellent, right? So what's the du with derivative respect to x? In this case, what do you get?
Oh, 6x.
Good, right? But look, we don't have a 6x squared, so we divide by 6, both sides. So we have 1/6 du equal to x squared dx. Then look, we can say that this will be 1/6 du. But then constant, we can take out from the integral symbol. So x squared dx will be du and sine u, right? All right, let's integrate. What is the sine u? Integral of sine u?
Minus cosine.
Minus cosine. Very good. So negative cosine u plus c, right? And minus 1/6 u, we should get back. U was 2x cubed plus c, right? That's how we do use substitution, right? Today, we're gonna learn Calculus 2. Look, what's the title? What's up? What's the title say that? Integration by parts, right? So we're gonna integrate by piece, all right? So look. Data? Let me just write down integration by part. Integration by part. If U and V are functions over X and have continuous derivative, then we have log integral of u dv equal to, we are using this formula, uv minus integral of v du, okay? So I'm gonna prove this one. All right, so let's say that we have the product f of x, g of x. Now, we're gonna derivative. So I'm using this order when we derivative, okay? So first one prime, f prime of x, g of x, plus f of x, plus g prime of x. So that student can remember easily because we have the same order, right? So f prime of x, g of x plus f of g prime of x, right? Now, let's integrate both sides, right? So integrate. All right, then what do you get this one? We have derivative, but then now we integrate. Then what do you get? With the derivative? Okay, once again, with the derivative, with the antiderivative, what do you get?
Just cancel out.
Yeah, so we get the original one, right? So we have, they cancel out. So we have just like this, right? Then, yes, thank you. Then we have integral of, so basically when we integrate, so whole thing integrate, right? So we have f prime of x, g of x. I must say dx, dx. Then we can split term by term. So we have this way, right? All right, now let u equal to, before we do that, let's arrange, okay? So I want to write down this way. So let me subtract. f prime of x, g of x, dx, both sides. Then we have f of x, g prime of x, dx equal to, I am writing down the left side. So we get f of x, g of x, minus integral of f prime of x, g of x, dx. Okay, now let u equal to f of x. Then what do you get? Du. We know that f prime of x du, right? I'm sorry, dx. Now, very good. Now we have v equal to g of x. Then we do derivative v, same thing, g prime of x, good, dx. All right, thank you. Now we just rewrite, okay? So f of x, I am rewriting everything here. F of x, which is u, g prime of x, which is dv, now f of x, g of x, which is u and v, minus integral of f prime of x, right, which is du, and this one is du, and g of x will be v. Can you see that? We have the same formula here, which we derive here. All right. So prove what's not that hard, right? So I just have a derivative of a product of functions, then integrate, that's it, right? And then let u equal to f of x, v equal to g of x, then we do derivative over u and v, right? That's it. All right. Then, how do we say that of u? Let me give you a tip. This u, we talk about u. So use for u. So we are using li. I don't know how you pronounce, other professor pronounce. So I'm using liate. So this one is for logarithmic or natural log, which is 7. Okay, thank you for letting me know. And I stands for inverse function, inverse trig function. And A is algebraic expression, algebraic function. So looks like x cubed, like a polynomial, like that. And T stands for trig, trigonometric function. And E stands for exponential, like e to the x power, like that. Okay, so we're gonna use u as those functions in order. That is much easier. Okay, then let us start easy first. So integration by part, we have a title. So basically this is, we integrate for product. So for using integrate for product functions. So you guys okay? Find x e to the x dx. Okay, so this one we cannot use sub. There's no way we can use sub because this is a product of two functions. We have to integrate. All right. All right. Then look, there is a tip. I cannot go more. Oh. Okay. Tip for setting up u, which is a log. We don't have a log there. And inverse trig, we don't have an inverse trig. And algebraic function, which is x. That is the third one, right? So let's set it up. U equal to x. Okay. Now, then rest will be dv. So let's see. This is u. This is dv. Because the formula said that, can you see that? U dv, okay? Now, we're gonna do uv and v du. So how do we do? Let me show you. Derivative, what do you get with derivative x? 1. 1 times, which is dx, good. How about we have a dv, which is e to the x dx, right? But then formula said that we have to have a v, right? How do we get the v from dv? We have a dv. Antiderivative, excellent. So we're gonna make an antiderivative to get the v, right? Then we have to do here too. So antiderivative. So with the integral of e to the x dx, what do you get? E to the x. Thank you. Excellent. So I have a habit. So indefinite integration, I'm using plus c. Okay, then we are following the formula. Okay, so we have u, which is x, v, which is e to the x, minus integral of v, which is e to the x, du equal to dx, right? I just follow every symbol variable, right? Okay, now we can integrate easily. Exponential function is easy to integrate. What do you get?
Oh, it's just e to the x
E
again.
to the x squared, e to the x plus c. Okay, so you can factor out e to the x because there is a common factor. We can leave it like this, that's fine. Okay. Okay, number 2. So this will be x sin x dx. All right, so once again, look, there's a tip. Algebraic earlier than trig. So we're gonna use x as u, okay? So u, then dv, whole thing will be dv, right? Let u equal to x, derivative, what do you get? 1 times dx, good. Now, dv, which is sine x, dx. Then how do you make a v, which is integral, right? Then what do you get? Integral of? So basically antiderivative of sine x, negative cosine x, excellent. Plus C. Okay, I have it. All right. I cannot move. Okay. All right, so we have the formula. So uv minus integral of v du. So u, which is x, v, which is negative cosine x, minus integral of v, which is negative cosine x, du, which is dx. All right. Now let us simplify the sine, which is cosine x dx. Now we can integrate. So antiderivative of cosine x, what do you get?
Is it just sine x?
Good, thank you. So sine x plus c, right? Good. Okay, number 3. Haha. Elena.
Sorry, Miss Lee. Can I just see again the previous the answer? Oh, yeah. Just 1 second. Okay, thank you.
Here we come. Done?
I'm done. Thank you. Thank you.
All right. So we have ln x dx. Okay, now we have tips. Tip. Use for setting up as u, which is log is the first one, right? So we're gonna set it up ln x as that. This is u. Then what's the dv will be? 1, excellent. So if we don't see that, there is an invisible 1 there, good. So this is dv. Or you can just think about dx. Yeah, that's okay too. All right, then let u equal to ln x, natural log, derivative ln x, what do you get? 1 over x, very good. Now, we have dv, which is dx. So 1 times dx, that's okay too. Then we want to find out what's the v. Then we take the integral, both sides. We get the x, antiderivative, excellent. All right, then we have formula, which is uv minus v du. All right, then u, which is ln x, v, which is x. So let me write down x here, okay? So that you don't multiply together with ln x and x, yeah? So I am writing the v in front, then minus integral of v, which is x, du will be 1 over x dx, right? Now we can simplify this one. Now we have 1 times dx. So we had a couple times experience already, right? What's the integral of 1 times dx? Excellent. So we have x plus c, right? Good.
Can I see again a little? Yeah, please. Thank you.
Okay. All right. Let me write down while she's writing. You might think, okay, now your turn. What we have to set it up as u. There is only 2 functions. Good. It's ln x. Good. Natural log. So then we can just rewrite, or be careful when you rewrite, right? So this will be u, and this will be dv. All right, then let u equal to ln x, du derivative of ln x. What do you have? One over x dx. Excellent. Now we have a dv, which is x dx. Now we want to find out what's the v. So we take the integral both sides, and we get the v. Yes. So we get 1 dx. I mean, so 1 plus c. Wait a minute. So look, we not derivative, we do integrate. Yeah, x squared over 2, right? So with the derivative, antiderivative, derivative, antiderivative. Yeah, we get confused easily. So we have x squared over 2 plus c, right? Yes, me too. Yeah, understandable, right? Okay, then we're gonna use uv minus v du. So u, which is ln x, v, which is, let me write down this way then. And that's the v minus integral of v, which is x squared over 2. Now, since we have only the simple one, let me take out the 1 over 2 outside of integral symbol, right? So we have x squared 1 over 2 du. Look, we almost forget du, which is 1 over x dx. Okay, now let me write down this way. 1 over 2 x squared ln x minus 1 over 2. So we simplify. So we have x dx. Now we have experience here. So we integral of x, which is x squared over 2. plus c, right? And this will be 1/4 x squared plus c, right? Okay. Now, what number for this one? Number 4. Number 5.
Hi, Mr. Can I make a
Oh.
quick question? How you ended up with two what is it? ln x and ln x. So two, what am I? ln x square and x square. Okay. So the three steps before
Third
this
step.
the
So
final, yeah.
1, 2, oops.
So 1/2 x square ln x.
So 1,
Minus
2,
1/2.
3. Third one.
3, 4. 4.
4. Uh-huh.
Yeah, that one.
This one.
Yes, I'm just trying to see where is
So
the
this one I
1/2
wrote down
coming
here.
from. Is that x2? Oh, I see. Okay, I see enough. Okay, thank you.
Okay, thank you. Okay, number 5. Find x squared ln x. Look, we have experience already. Let u equal to what? Ln x squared, right? So u, then this will be dv, right? Let u equal to ln x. Derivative ln x, we have 1/x dx. V dv, which is x squared dx. Now we do antiderivative, which is v. What do you get? Antiderivative.
X to the third over 3.
Thank you. X to the third over 3. Okay, now we are using uv minus integral of v du u ln x v x cubed over 3 minus integral of v, which is 1/3 x cubed du, which is 1/x dx, right? Very similar with the previous example. So we have 1/3 x cubed ln x. Because I don't want to multiply, that's why I'm writing in front x cubed minus 1/3. We do simplify, which is 2. So we have x squared dx. All right. Now we have experience here. Can you see that? So integral of x squared, which is x cubed over 3. So we are using that. Okay, so this will be ln x minus 1/9 x cubed plus c, right? So I don't like parentheses there because there's plus minus, yeah. All right. I want to pause a little bit because you guys need to write down, right? Number 5. Number 6.
I have a quick question.
Mhm.
Would the minus sign, like, why wouldn't the minus sign like distribute to the C? Is it because C is a constant? It doesn't really
Yeah,
matter.
that's why I don't want to put the parentheses.
Okay, thank
Yeah.
you.
You're welcome. That's why I take out the parentheses, right? Yeah. Okay.
I have a question.
Uh-huh.
This video is going to be uploaded to your YouTube, right?
That's correct.
Thank you.
Thank you. All right, number 6. So we have ln x and x cubed. Same ln x, right? So what do you want to have u? Ln x, right? So u equal to ln x, natural log, and this will be dv, right? So u equal to ln x, derivative of ln x, we know that 1 over x dx. Now dv is, which is 1 over x cubed dx. Now we want to have v, right? Then we do integrate. Since we do the left side, we must do right side too. All right, so we're gonna use the power rule. So we can think about x to the negative 3 power. Then what do you get?
X to the negative 2 over.
Good. So we have x to the negative 2 over negative 2. Good. All right, then uv minus integral of v du, u, which is ln x, v, I am writing down later on, simplify, minus the integral of v, which is negative, positive, right? So 1 over 2, and then x to the negative 2, and then du will be, ooh, it's 1 over x dx, right? You guys okay? All right, then negative ln x over 2x to the second power for the first term. Then second one has 1 over 2. Now the second one has x to the negative 2 power, which is 1 over 2x squared. So we will have 1 over x to the third power, right? Now look, integrate x to the negative 3 power, then we have this one, right? So we can use that. This will be negative ln x over 2x squared plus 1/2. And we have x to the negative 2 over negative 2. Let's see. So this will be negative ln x over 2x squared minus 1 over 4, 1 over x squared plus c. Okay. Let me pause a little bit.
Miss Lim, why x 1 over x to the cubic? Why the 3?
What is the 3? Here? You meant here, right? Here?
Yes.
Okay, so we have x to negative 2 times the 1 over x, right? So this means 1 over x squared. Yeah. Or you can say the negative 2 minus 1. You can do that too.
Is that 1/4 and then the 1 over x squared? Are those multiplying each other? Is that on the bottom line here?
On the bottom line,
These fractions that are right next to each other, the 1/4 and the 1 over x squared,
mhm,
are they just multiplying each
yes,
other?
uh-huh.
Okay.
Do I make a mistake? I don't make a mistake, right? Yeah, it's multiplication. Or if we don't like it, maybe we can write down this one for, yeah. Okay, number 7, we getting to advanced 1. So far so good, right? All right, so look. We have x squared e to the x dx. Okay, exponential always the last one. So u will be x squared then let u equal to x squared derivative. What do you get? With the derivative x squared, 2x, very good. Now dv, which is e to the x dx. Now we want to find the v, then we do integrate both sides to find the v. Then what do you get? Antiderivative of e to the x? Yes, e to the x, very good. Question? All right, so we have uv minus the integral of v du. So u, which is x squared, v, which is e to the x, minus integral of v, which is e to the x, du, which is 2x dx. Yeah, this one. But I'm gonna take out the constant outside of integral symbol, right? So we have 2x dx. Okay. Now, x squared e to the x minus 2. Look, we cannot integrate directly, right? Because this is always a product of 2 functions. Now, what do we do? Do again, good. So we're gonna use integration by part again. So what do you want to set it up as u? X, good. So this is a u, and this will be dv, v. All right, so we do again. By the way, integration by part, we use IBP. So integration by part, okay? Okay, u equal to x, derivative of x, what do you have? 1 times dx, good. Now dv, which is e to the x dx. Now we do antiderivative to get the v. Then we know that exponential function always nice function. So we have e to the x plus c. Okay. Now we do again. So uv, look. uv minus integral of v du. Okay. U, which is x, v, which is e to the x, minus integral of v, which is e to the x, du, which is dx, right? Okay, then we have x squared e to the x, minus 2, x e to the x. All right, so we have to distribute -2, and then what's the integral of e to the x dx? We know that e to the x. So negative, which is positive. So we have a positive 2 e to the x plus c. Is it okay? All right. How about if we can use just u substitution, we can use u substitution, right? Because why we are trying to do a longer way, right? Mathematician always trying to look for easier way, right? Okay, so if you can think about the use of just right away, yes, you can use that. But those are things, what I'm doing right now, those are things we cannot use up, all right? That's why we have to use integration by part, all right? That's a good question. Okay. Okay. Can you hold a little bit? So I can answer later on because we have only 10 minutes. So I want to finish number 9, 10. Oh, 2 problems. Yeah. Thank you so much. Okay. All right. So actually, this is number 8, right? I prepared the number 10, but since we don't have time, I want to skip one problem. All right, so example number 8, we have e to the x sine x, oops, dx. All right. Which one is you? Okay, thank you. So exponential always last, right? Logarithm always the first, right? So u will be sine x, then dv will be this. Good. So let u equal to sine x. What's the derivative?
Cosine.
Yeah, so we derivative, then cosine x, good. Now dv, which is e to the x, dx, we're gonna find v, then antiderivative, then what do you get? We have e to the x plus c, right? All right, now we are using uv minus integral of v du. U, which is sine x, v, which is e to the x, minus integral of v, which is e to the x, du will be cosine x, right? Now, we have to do again, right? U, what do you want to set up as u? Cosine x, good. And this will be dv then. So we have let u equal to cosine x. Derivative of cosine x, what do you have? Negative sine x. Ooh. Now we have a dv, which is e to the x dx. We find the v, which is e to the x plus c, right? All right. So let's see, e to the x sine x minus u. U is cosine x. V, which is e to the x. Let me write down for you. We have uv minus integral of v du, right? Okay, then minus integral of v, which is e to the x du, which is negative sine x. I often omit. Yeah. All right. Look, e to the x sine x minus, let me take out the parentheses bracket, cosine x e to the e to the x power, and minus minus we have a positive, but then we have another negative sign, so we have a negative e to the x sine x dx. All right, let's take a look. Look, can you see the original problem? We get the original problem. We don't want to go over and over and over and over. Can you see that? If we do that, we get this. We get this, we do that, then do again, repeating, right? So what we do in this case, so let me arrange this in this case. So original problem, I'm gonna rewrite this one here. So we have e to the x sine x dx, which is equal to the last step. I'm gonna rewrite e to the x minus e to the x. Which one? U equal to e to the x? Oh, no. We see. I see what you meant. All right, then look. I want to add this one. Right side. Since we add this one, we have to make a balance, right? So left side as well. Then we can simplify. Okay, now we have two of them, right? So we have 2 of e to the x sine x dx. Then we have e to the x sine x minus e to the x cosine x, right? All right, then we divide by 2 every term. So we get e to the x sine x dx, which is they have a common of 1/2 e to the x. We can factor out sine x minus cosine x, or you can just leave like that, whatever here. Okay, so this is the final answer. So you guys okay? All right, so let us do the last problem, okay? We do integration. Why? Because we want to find the area under the curve, right? So I want definite integration at this time, okay? So number 10, number 9. Find the area of the region bounded by the graph of y equal to arctangent and below by x-axis over interval 0, 1. Okay, hold on for the question. Okay, so let me finish this one and then I'll take your question. All right. And I'm gonna bring the picture here. So we want to find the area under the curve, which is arctangent, right? Okay, then look. That's why we need the integration, indefinite integration. I mean, definite integration, right? So look, area from 0 to 1 and inverse of arctangent. Okay, so how do you want to set it up as you? Inverse function is the second order, right? So you, and we had experience if there is nothing, then invisible one. So this will be dv. Okay. All right, then let u equal to inverse of x. Derivative, what do you get? You had the homework from the inverse trig function 1.7. I gave you this kind of a problem. What do you get? It's 1 over x squared plus 1, right? We do derivative. Now dv, which is, oops, 1 times dx. We do antiderivative. V, what do you get? X, good. All right, then we are using uv minus integral of v du. So that is u, which is inverse tangent, v, which is x. Let me write down in front, minus, hold on 1 second. This is a definite integration. So I'm gonna make it from 0 to 1. Integral of v, which is x, du will be 1 over x squared plus 1. So it's better we have this form. Okay, oops, x. All right, now we have 1 times inverse of tangent of 1 minus, and everything is 0 for that, minus. Okay, what can you see? Second term of integration.
Is it just 0 or?
No, second term of this one. I'm talking about the integration.
Oh, I guess I didn't understand your question.
Okay, so look, if we are using u sub, this is a u sub, not the, let u equal to x squared plus 1 derivative, then what do you get?
2x.
2x, good. Now we don't have a 2, so we divide by 2 both sides. So we have 1 over 2 du equal to x dx. All right, so look, we have 1/2 x dx will be du and over u. What do you get this one? 1 over u. What about this one? ln x, good. So ln u, right? So ln x, right? So it will be u was x squared plus 1, which is a positive, so we don't need the absolute value. So we have 1 over 2 ln x squared plus 1 from 0 to 1. All right, so what do you have this one? Inverse of tangent of 1. Okay, think about that. What's the theta will be? Theta will be. What is
45.
45 degrees, which is pi over 4, right? Good. So we're gonna use pi over 4 minus 1/2 ln 1 plus 1 minus too many parentheses. Okay, ln 0 plus 1. So we have pi over 4 minus 1/2 ln 2. And look, ln 1 equal to 0, right? Okay, so this is the answer. Can you make an approximate this one? Pi over 4 minus 1/2 ln 2. Okay, 0.4388. Thank you so much. All right.